Today I will present about the introduction of the study related to the number of students' daily screen time. Screening time has become an essential part of students' daily lives. Students use screens not only for entertainment, but also for academic work, communication, and daily activities. Because of this, it is important to understand how much time students actually spend on screens instead of relying on assumptions. In this study, the number of hours spent on screens each day is treated as a discrete random variable. Each student contributes one observable value which allows us to analyze the data statistically. This study is necessary because there is limited class-specific and data-driven evidence showing the actual screen time of students. Without the real data, assumptions about students' behavior may be inaccurate and may lead to misunderstandings about time management, academic performance, sleep quality, and overall well-being. By collecting real responses from students, we are able to calculate the empirical probabilities based on observed frequencies. This helps us better understand students' behavior and also strengthens the application of statistical concepts in real-life situations. The main objective of this study is to identify the probability of daily screen time among the students by analyzing the number of hours spent per day as a discrete random variable and computing probability values based on observed data. So by conducting this study, it provides clear evidence about students' screen usage, increases self-awareness, and enhances the practical understanding of statistics in real lives. That's all from me.
I'm Nurin Karina will explain the methodology that we use to analyze daily screening time among students using Poisson distribution. So first, the data were collected using an online questionnaire created with Google Form. And then the Google Form was distributed to all students and 46 students are responded. Each respondent reported the number of screening sessions per day, such as checking phones, laptop, or tablets for study, entertainment, or social media. The data collected are count data, so they are suitable to be analyzed as a discrete random variable. After checking for completeness, the data were organized into a frequency table. This organization allowed us to apply the Poisson distribution and interpret students' daily screening patterns effectively.
This slide explains how probabilities and variation in students' daily screening time were analyzed. First, the random variable x represents the number of hours students spending on screen per day. To determine the probability of each screening time category, an empirical probability distribution function was used. This method calculates probability by dividing the frequency of responses in a specific category by the total number of respondents. Next, to analysis the variation in daily screening time, the Poisson distribution was applied as an approximation model. Since the data was grouped, mean point values were assigned to each screening time interval to estimate the mean value lambda. By using the Poisson probability function, we were able to assess the variability in screen time and also can determine the like, likelihood of this different screening time duration occur. These approaches provide a clearer understanding of both the distribution and also the variation of student daily screen usage. This slide provides an overview of the study results. The study surveyed 46 students to analyze their daily screening time. The raw data is in appendix, and here we present a summarized version using frequency and also Poisson probability tables for easier interpretation. This table shows the frequency distribution of students' daily screen time. Most students spend 4 to 6 hours per day on the screen, while no student reported less than 2 hours. This suggests that moderate daily screening usage is common among respondents. Here is the probability distribution. The highest probability is 0.457, corresponds to 4 to 6 hours of screening time, confirming it as the most typical range. Categories with extremely low or high screening time have smaller probabilities, indicating fewer students will spend that much time on screen. To analyze variation, the Poisson distribution was applied. Midpoints were assigned to each interval, and the mean daily screening time, which is lambda, was calculated as 5.65 hours. This approach allows group data to be used in probability modeling. To analyze variation, the Poisson distribution was applied. Midpoints were assigned to each interval, and the mean daily screening time, which is lambda, was calculated as 5.65 hours. This approach allows group data to be used in probability modeling.
I'm Laila and I will explain for discussion part that we use to analyze the daily screening time among students using the Poisson distribution. Based on the frequency and probability distribution, the result indicate the majority of students spend a moderate to high amount of time on screens each day, with the highest probability, which 0.457 corresponds to students spending between 4 to 6 hours daily on screen-related activities, this making the interval of the most representative of typical students' behavior. In contrast, no respondents report that spending less than 2 hours per day on screens indicates that minimal screen exposure is uncommon among the sampled student population. The probability distribution further shows that a considerable proportion of students that spend more than 5 hours per day on screen, with the categories of 6 to 8 hours and more than 8 hours, each accounting for a probability of 0.174. These results reinforce the importance of analyzing the actual data rather than relying on assumptions when discussing the students' screen habits, as empirical probabilities that provide a more accurate reflection on real world behavior. The relative high value of mean value that indicates that students are generally expected to spend several hours per day on screen, and the Poisson model shows that the screening times tend to cluster around the mean rather than the extreme low values. The results obtained from the Poisson analysis are consistent with the empirical probability distribution, as both demonstrate that moderate to high screening duration are more likely than very short durations. This consistency strengthens that the validity of the findings and confirm that student screening behavior exhibits an noticeable variability while remaining the concentrated around the average range of 5 to 6 hours per day. The discussion highlights how probability distribution can be effectively applied to analyze students' daily activities. By using real questionnaire data, the study successfully demonstrates the relevance of statistical concept in understanding behavioral pattern, particularly in relation to screen usage among university students.
Hello, my name is Brittany and I'm a colleague with my registration number is CN240185. Here I will be presenting our conclusions for this study. For this study, it has examined daily screening times of students while using empirical probability distributions and Poisson distribution. It's based on the data gathered from 46 participants that we were collecting through Google Forms. It has been found that most of participants spend between 4 to 6 hours a day on the screen. a large number of which exceeds 5 hours, thereby it establishing that a large number of participants use screen intensively. The calculated average value of around 5.65 hours has established that a large number of participants use screen around the average value and not around very low value. Although very minor errors were found to occur in this scenario, which happen because of data being in groups and values being taken around the midpoint. Poisson distribution has been found to be consistent with empirical probability values and has been able to establish variations of participants since participant screens use effectively. That's all from me. Thank you.